Hello and welcome. Are we streaming? Are we live? I assume we're good to go. So, hello and welcome. Did you guys enjoy the keynote?
Yeah.
I like debugging my thinking. I was looking at the description of that, and it just sounded like a great and cool talk. I'm going to watch the recording of it, hopefully after this is done. Unfortunately, I was up here kind of making sure everything else was going to work so that when we get started here, we can dive right in. My name is Mike Benkovich. I'm a developer, I think of there's architects and there's engineers, and engineers are the ones that kind of get things to work. Architects kind of draw boxes, connect the lines. Is there any architects in here? Sorry. No. But as an engineer, it's like, how do I make stuff work? And over the last number of years, I have dug into infrastructure as code as one of those stools, one of those legs of a stool of a well-governed cloud. A well-governed cloud is one that has some consistency. It's got tagging, naming that's predictable. It follows some good patterns. It's something that you can live with. And building a well-governed cloud is kind of a journey. You know, we start at point A and we try to get to where it really makes a lot of sense. I come from the US. My sponsors are up there. You can see my wife and daughters from Minneapolis, which is near the Great Lakes. If you've heard of Lake Superior, that's part of our state. It's at the top of our state. If you've heard of, what's it called? Father Mike, Bible in a Year, he's up there. The Honeycrisp apple came from Minnesota. We had this artist formerly known as like this unpronounceable symbol. He lived down the street from where I live. But I'm right from that part of the US. I do a Azure office hours every Friday, which is 15 minutes, talk about anything cloud, anything engineering. If you want to talk after this, if there's questions that I forget to talk about or whatever, feel free to reach out to me. I'd love to hear what you're doing, and if I can help with an answer, that'd be great. If I don't know the answer, I can make something up, or I could give you the consultant answer. It depends. But seriously, I like to try to stay in touch, and I'll be here at the conference all day, all week. So if you want to talk about any of this stuff, Azure Office Hours, again, it's on my blog. So if you go to benkotips.com, let me see if I can do that here. See. So this is my blog, Benko Tips. On the left-hand side is some useful links. So there's the Talk to Mike. There's the Azure Office Hours. Here's a site we're going to build today. It's called Ask Dad. It's a very important site. It's got all kinds of wisdom on it. But I run a bunch of other things that are like that. To get started, because we're really going to be digging into this, is what are we talking about today? What do you want to get out of today?
Should I be using ARM templates? Should I be using Terraform?
Should I be doing ARM or Terraform? Great question.
When I should be doing ARM and when I should be doing something else.
Okay, so when does it make sense to look at the other options? What are the trade-offs? Good questions. What else? Yeah, back here.
Given that Bicep is now a thing,
Mm-hmm.
is there ever a need for ARM templates anymore?
Oh, great question. Because Bicep is like a replacement for ARM? Or is it a replacement for ARM? That's the kind of the thing, is that Bicep is a tool to do ARM. ARM is still the native language. So I kind of want to talk about what is infrastructure as code and why do we care? Why do we need infrastructure as code? What's its purpose? How does it fit into our list of things that we do? We'll talk about ARM and Bicep. We'll talk about Terraform. We'll talk about Pulumi. I've got a little bit of Ansible. I've got some other options of things you could do to create infrastructure as code. But really, the purpose of infrastructure as code is to create infrastructure that we can use to run stuff on. And that infrastructure might be in AWS, it might be in Google, it might be in Azure, it might be on premises. I might need to be able to go out and create something like a server farm, run a website. An application is really taking an idea, adding some code, maybe a little bit of data, and then running it on some infrastructure. Cloud application is one that's running on virtualized hardware, which means I can spin up and pay for what I use. It's monitored, configurable, scalable. It does all of those kinds of things. A basic web app that we're going to do today is I created for us a project. And this is, if I go to the home page of this, and let's close all the others except for this. This is my application I created. I did this by going out and doing a .NET new Razor web app and basically created this web application. It's pretty much what it created. Inside of my source folder, I've got a folder that's got some pages. I've got a program file that starts everything up. We're going to just add something to our home page, and that is being .NET Core 8, I think is where we're at today. And if you've done a little bit of Razor or web pages, you know that I can use the @ sign to do codey kind of things. So I can do an @ using Microsoft, and I can use the extensions EX, if I get my fingers in the right place, extensions, and I'm going to use configuration. Configuration is nice because I might want to be able to go out and read configuration values as I'm running stuff. So if I inject an iConfiguration object, configuration object, call it config, and you can see how well I'm typing today. But I can come down here to where I say here, I'm in the welcome, and I'm going to go over here and I'm going to do a bold tag, and we're going to put in here @config, and we're going to read a value called env name. And with that environment name from the configuration, right here, I can read that from a file called the app settings, which is down here, app settings JSON. And you can see I've got an environment name variable I added called local. I have a favorite color too. My favorite color, what's your favorite color? Dark blue? Ooh, let's go navy. All right, that's close enough. But in order to use that, I would have to add some code to do something. So I've got a dad joke. Now I've got GitHub Copilot on here, and so it makes recommendations as I type. And if it doesn't, I've got some code snippets that add exactly what I want. So what I'm going to do is I'm going to add just a little bit of code here that's going to go out, and it runs this thing where it goes out to an API, replaces it, and we end up with a joke. I'm going to do one thing here, which is in the H2, I'm going to have a style. I'm going to say my background color. I'm going to set up the value @config, reading in our favorite color. And with that, if I do an F5 and run this, it'll go out and build it for us. If you're a Visual Studio person, you click the F5 and it goes out and builds it. Does the same basic thing. But you can see now I've got this, and you can see why dark blue doesn't really work well with a black font, right? So we could fix that by simply going over to our configuration. And let's go into this. And in our app settings, change that back to, say, light pink. Light pink. And restart. And by the way, live code is fun. There, look at that. It's like we got our favorite application, the dad app. My kids come here, they get the whatever. Yeah, it's made out of hide. And if I do it again, yeah, I'll meet you around the corner. All right. Anyway, as you can see, my app is ready for production. And I want to run this somewhere. So in order to do this, I can go into my application and I can say, okay, I'm going to do this. We'll stop this crazy thing. I'm going to go over here to where I've got my .NET New. I added this code and I added a solution file. So if I go here to this and I say dev environment, DEV, which happens to be Visual Studio, and I say the name of it, NDC London, NDC 24 London.sln. It'll go out and it's going to open up Visual Studio for me, and I'm running Visual Studio 22. And I can take this and I can then go out and say, let's go ahead and run this in the cloud somewhere. And there's the same code. There's our app. In Visual Studio, I can right click on here and I can say, go out and publish. So up here in publish, it opens up the page where I can publish into a cloud. I can either run it locally or I can go to Azure. This is a session that's focused on Azure. If I was doing AWS, I would have the AWS extensions installed. But you can see I can go to a app service, I can go to Linux, I can pick where I want to send this, click on next, and then it says, okay, you need to go out and sign in. So if I sign in and say, yeah, we're going to go ahead and log in, it goes out, pulls up my dad dev Azure subscription, where I've got a sandbox, and I can say create new infrastructure. Nice thing about this is it gives me some beautiful names that are very easy to remember and a bunch of defaults. And I can say, hey, go out and create this and just say, yeah, all right. So we'll create a new subscription or a new resource group. I call this RG London 24 demos and say, okay. And then I can put it into an app service plan. Once it confirms this, we'll call this my dad app. Call it LON24 dad app. And you can see I can click on export right here to be able to export. And what that'll do is it'll create that JSON ARM template for me that I could use to go out and do my deployment. And then I say, hey, we've created an ARM template, we're done. Okay, what else do you want to see? Reality is, this is going to use a default template that's in the project that isn't that great. If I go ahead and click on create, it'll actually go ahead and run that for me inside my Azure subscription. When I go over to my browser here and I am on Azure, if I go and see my resource group and I search for anything that's got London in the name, and I refresh, and I turn off that guy, eventually, this is going to create the app service, and I would be able to see that deployment inside of my Azure subscription. And refresh here. There's my London 24 demos. Open it up. One of the nice things about ARM templates is that it's working with the Azure Resource Manager. What is the Azure Resource Manager?
It manages resources.
Manages resources, right? What kind of resources does it manage? All of them. So the model that it works on, they went from the classic, which is the old way that we did Azure before, where it was a very convoluted, tightly connected, coupled thing that it was a little bit on the hard side. I can tell you stories about that later. But what the Resource Manager is it's a standard model, a REST set of APIs that you can go out and call to be able to provision things inside of Azure. If I look at my Azure and I go to my Azure subscription, suppose I go over here and I say open up, and I say, how do I do this? I want to say duplicate this. There it is. And I'm logged in here as this. And I look at my subscriptions, because we go to the home page and I say, here's my subscription for the Dev Sandbox. On the left-hand side, you'll see resource providers. There's resources, but resource providers are the list of everything I can create inside of Azure. And every one of them has a REST endpoint that I can go out and call to create, update, delete, and work with. The way ARM works, ARM templates and Terraform and other ones, is they orchestrate a bunch of calls to those REST endpoints to be able to go out and create stuff inside of Azure. The way ARM templates and Bicep work is it creates that template as a JSON representation of what those calls are, the order that things need to go. Basically, I can structure how I want that to go out and work. If I use Terraform or I use Pulumi or other tools, it doesn't necessarily have that ARM template, but it saves it in the format that Azure has, which is actually stored in something called resources.azure.com. So if I go to resources.azure.com, I don't know how many people have been to this site. You might not even have known it exists. But this site has all of the resources for my currently logged in user. So I can say, here's my subscriptions, and I can see there's the providers that are on there. I can say, here's my dev sandbox. And if I come down here to resource groups, I can find my way to where I've got the resource group that we're going to be working with, which would be my London 24 demos. And in here is all the resources that have been created within it. This is the Azure state. If you're familiar with Terraform, this is how Azure keeps track of what's actually been created. And so from a templating perspective, understanding that this is where stuff gets stored is kind of an important part of the whole story of how do we pick and choose the right tool for what we want to do. Coming back over here to Visual Studio, yeah, I could go out and I could say deploy this, click on finish. It'll go out and build that, and then we could publish it. It creates a published profile, and then I can close it, and I can say go ahead and publish it, depending on how fast it is. It may or may not get there really quick, but then you could go out and you could go to our dad app that we wrote here. It'll be on there forever until I delete the resource group. But it'll basically give us the opportunity to go out and work with that. Now, creating infrastructure this way, I could also have gone into the Azure portal and said, create a new web app and done the clicking around. The trouble with that is how repeatable is it? How do I make this so that it's something that has naming stamps? It's like I'd put the name on here just, okay, what do you think we should name it? If you do your standards that way, it's sort of like if you don't know where you're going, any road will take you there, but try to find your way back. So anyway, while this is going out and it's going to publish, and when it's done, we can see that it's pushing up all of the different files it needs, and it's done. It'll go ahead and open up the app for us. We can see that it's going to be out there and running. And so the London 24 data app on the websites should be up here in a minute. While that's coming up, I can click on this. You can see here's the site. And eventually it'll come up and you can see that it's going to work. First time it loads .NET. Pretty cool. Well, sort of that way. If I come over here and I'm looking at my resource group, I can see here's my deployments. There's the actual deployment it ran. If I open this up, I can see here's the template. And this is the ARM template it used to go out and create that deployment. Inside of Visual Studio, I could also right-click here and say, hey, let's add a new project. And this is the thing I was saying that we may or may not have time to do. But I can go out and I can create a new project for a resource group, search for resource. And resource group project type has a starter template. So I can call this my VS deploy. And I'm going to put this into a folder called infra. So I'm going to go here and say /infra. It'll create a subfolder called Visual Studio Deployment. And it gives me a starter spot, which are some starting templates. Things like a Fabric cluster. I've got a web app with SQL. I could do storage and CDN. But there's some starter templates I can work with. And if I go out and I pull this up and I say, OK, what it's going to do is it's going to create for me that starter template, but I'll be able to edit the template inside of Visual Studio to do things with it. So over here on the right-hand side, you see I've got the website.json and some parameters. If I open this up, you'll see here's the values. Inside of ARM, I've got the ability to describe the sections of this. So I've got parameters, variables. Wow, it's got variables. Resources. As you'd expect, the ARM schema is not that complex, but the stuff that's inside of it is what define how this is all going to get built out and deployed. So from the parameters, I can see that the parameters, for instance, one of the parameters is going to be the SKU that's running. I can edit these and say, I only want free and premium 4. If I right-click on the VS project, there is a deploy script that I can run. I can go say, right-click and say deploy, create a new deployment. Again, it's going to go out. I can pick the resource group being our, switch to our dev sandbox, go here to our London demos, And then I can say, here's the website. And then I've got parameters that I can edit. And this is where I can put in values for parameters that are coming in. So for instance, I've got the resource group location. It's going to use that location. The web app name, if I do this in the right way. So I've got some functions I can run. I'm running a format of web app dash and then a GUID. I've got the SKU that it's going to run is .NET, and it's going to be an F1. If I click the drop down, remember we made F1 or P4, so we can go free or pay a lot. Save that, click on deploy, and what it does is it's going to go out and it validates that ARM template for me, and then it'll run a PowerShell script to go out and do that deployment. Okay? Nice thing about the editor inside of Visual Studio is that when I'm using this, I can either look at this like this, or I can go up and I go to search, and I search here on the search window, I go search for JSON, type in JSON, and that pops over here. But basically what it does is it opens up, here's my mouse, this JSON outliner, which has got all of the different parts of my template. So you can see I've got parameters, I've got my variables, and I've got the 3 resources that can get added. I can right click on this and I can say add a new resource, like say we decide we want to add a SQL server. A lot of times you got applications, you got this stuff called data. If you could just get rid of the data and the users, we'd have perfectly safe software. We would. But I can come over here and I can say, well, let's add a SQL database, right? I put the name on here, we'll call this demo DB, and I'll pick a server, and I'll say create a new one. We'll call this my London 24 DBMS, and I'll add that. And when I do, you'll see that it highlighted over here on the right-hand side a whole bunch of stuff. So over here, you can see it added a bunch of parameters for me for the login. So I've got the login, I've got the DB name, I've got the edition, database name. The neat thing about this is that now I could use this template and I could deploy it. So let's go over here and say deploy. And we're going to do this again, but in my parameters, it's going to recognize that it needs a few more things, like the repo URL. If I have a repo with code that I want to deploy with this, I could push that. But I've got the SQL admin login, which I think everyone knows it's SA. Actually, SA won't work because it'll tell me, no, you can't use that. But we'll go SQL admin, and then we'll put the password here. I'm just going to type in the super secret SQL password. And we'll just save that as plain text so we can check it into GitHub. I'm sorry. I'm such a funny person. I can click this button over here, though, and I can say, no, use a key vault. And I can enable this deployment to work with that key vault so that I can deploy and keep my secrets secret. That journey to a well-governed cloud, one of those steps is like, are your secrets really secret? How do you keep that safe? I find this to be one of my more favorite parts of this particular example, is that you can wire up with the key vault. Yes?
Why would I even want to deploy from Visual Studio?
Why would you ever want to deploy from Visual Studio? Very good question. Maybe I've never done anything else. Maybe this is like my first foray into cloud. And so as someone who's starting out with cloud, okay, I can do it. But like you say, what's the benefit of that? Because I'm doing this deployment and I'm presumably running it manually instead of in a DevOps pipeline, right? And GitHub Actions and Azure DevOps and AppVeyor, there's all kinds of tools that can go out and do that exact same thing, but do it for me. So I'm not the person doing that. And that's exactly the problem with doing this type of infrastructure as code. It's possible and it's a good starting point, but there's better ways. So I just wanted to show you that this is here, that this is possible. I'm not going to actually do any more with it. So any other questions about Visual Studio before we move on? Visual Studio is great, nice tool. I used to be a Visual Studio evangelist. I used to do a lot of Visual Studio. My favorite editor, I couldn't imagine doing a talk without it, but anyway. VS Code is a nice editor too. And I'll show you kind of how it works a little bit better. But when you're looking at, how do we pick which infrastructure as code makes sense for us, which tools do we use, comes back to understanding, how they interact with other tools that people already have. The other people on my team, what do they currently use? If I go into a client and they're doing Terraform, guess what I'm going to do? Terraform. If I go into a client, they're doing Bicep, guess what I'm going to do? I'll probably do Bicep, unless there's things that Terraform, like we're going outside of Azure and doing something different. So, if they're doing Pulumi, we learn the tools that make sense, but does the organization pick the tools and then we go do it? Or do we get a chance to make recommendations? I think it's good if we can make recommendations. There's a lot of options, and I kind of went through Visual Studio, but let's talk about creating infrastructure as code that's repeatable, versioned, managed, that has the opportunity for it to be idempotent, keep things from the environment drift, be able to stay current with what our infrastructure should look like. We talked about ARM, declarative way to go out and work with the resource provider, one or more resources. It's great for getting started. Each resource gets translated into a REST call. The basic structure of an ARM template, you've got your parameters, variables, resources, and outputs. In a DevOps pipeline, I use the output section to set variables in the workflow to be able to run other steps. So being able to connect between different stages of that deployment. Parameters, that is how I take the template and I make it so that things have to have like an environment name, an app name, and I calculate all the value names for every service that we create. And I do that in a variable section so that I can reuse that, and I can enforce that as a coding pattern or encourage that amongst my code developers so that we write code that is supportable. And whether I do that in ARM or I do it in Bicep or I do it in Terraform or I do it in Pulumi, if I've got a pattern that I like working with, it just makes it that much easier to own. Inside of an ARM template, you have resources. Each resource section is a block that tells me what provider am I going to be talking to. Remember the Azure providers? And there's different versions of schema that they publish. So those REST endpoints, they are backwards compatible, so I can use what, I have to pick which version I'm going to be using. Then there's specific things that are particular to like the storage name, the SKU depends on. Tags are another part. Having a consistent tagging pattern allows me to say, hey, put a tag on that this is marketing, put a tag on this is HR, this is manufacturing, and being able to break down your Azure bill according to by tag to say, okay, well, here's how much we spent on each of these different areas. But if you don't enforce or think about those tags, people create stuff that's out there and it's just like trying to guess from the name, what is it that we're looking at? Working with ARM, Visual Studio, we saw the resource group project. VS Code has got a really nice ARM extension to create a simple ARM template in here. So here's my infra folder. If I create a new folder here, I'm going to call this ARM. And if I rename that to be correctly, ARM. And then in here, we're going to create a file and call it mysite.json. And if I type ARM, it's going to go out and it's going to turn on the ARM template. I can make this a little bit bigger here. But it's going to load an extension for me. If I look for ARM on the extensions, I've got the Azure Resource Manager extension installed. And one of the cool things about this extension is it takes it about 2 minutes to load the ARM schema, which if you're doing a live demo and I go out and I start typing things in and I expect it to give me all the IntelliSense and all of the other stuff, it doesn't work. Guess how I know? However, I do have GitHub Copilot installed. And GitHub Copilot is great because it will throw out some random suggestions based on today that were maybe useful last time I did something like this. GitHub Copilot is my, do we call it an intelligent assistant? Maybe an informed assistant. It's informed about what my patterns are, and so it can make some recommendations or suggestions based on things. But whether or not it actually works or not, I don't know that I trust it. But coming back here, you'll see that here's my parameter section. I usually will have some required parameters, app name, environment name, and maybe some other things. So if I do a parameter, I can create a parameter called app name, and it's a type of string. I create another one. I could use it to go out and create this, like my environment name. One of the things about this snippet is it does include other types of properties of what that parameter is. So it's got metadata, which has got the description. I might have a default value. So in here I can say, yeah, here's this. And I can say string, and I can say default value, and we'll give this default value. If I go like this, do a colon, quote, we'll call this arm, and then boom. I can come down, I can create some variables. Variables are in ARM, use a syntax with a square bracket to put functions together. So in here I can say, here's a variable, we'll call this my app or my site name. And my site name I'm going to pull in and concat. So let's do this, concat, and we're going to pull in from the parameters. And I'm going to pull in a parameter for the app name. I'm going to do a dash, and I'm going to do another parameter for the environment name. And then I'm going to do dash site. And the nice thing about the editor in here is that it's pretty good. You can see that it's highlighted. This is kind of a lighter blue because it says I haven't used it anywhere. It's got kind of a warning on it. If I do the host name the same way, and I let ChatGPT, I turned ChatGPT off for this. Concat, and then say parameters and app name and parameters. Environment name, comma, tick dash host. And then I can come down and add resources. And in the resources, I can just start typing, and I can say, like, plan, and it would go out and say, here's an ARM plan. And it would then fill in all of the pieces I need for what this would look like. And then I could use that to be able to go out and create my resource. I'm going to use my Linux snippet I created, and I've got a Linux plan, and I'm using the variables here for my host name. And then I'm going to come down underneath that, and I'll add another Linux website. And just so you know, like, not only am I coding in front of a live audience, I'm not coding on this machine, I'm coding on that screen, and so it's like I have to look over here while I'm typing, which is extremely difficult, right? Sorry, I shouldn't complain. I'm so happy to be here. Linux site. Truly I am. Nice thing I like about the Visual Studio Code is you've got the editor where you can do a Control-D and select all of the instances of the same thing, and I can say, hey, we're going to do this. These are variables for our site name, and edit it in all the different places. And then I come over here, let's get rid of that, get rid of the tick, and I'm going to do variables of the host name. And then I come down to this part where I've got resources, and inside of this, then I can put into this here my configuration. No, it's my app config. And in my app config, we'll use the variables for my site name, and then I'm going to put in some values here for my env name, and we'll put in this is going to be ARM, and my favorite color, light green. I don't know. Do we like light green? But I can take this, and this allows me to go out and edit and work with the ARM template syntax very quickly and easily. The editor is very powerful. The extension inside VS Code is really worth using. It gives you a lot of good feedback. You can see on the side where you've got syntax errors and things like that. I'm going to add here, just because I'm a little bit on the lazy side, I'm going to go into my infra folder here. I'm going to add a file. I'm going to call this my test IaC.ps1, a PowerShell script. And look at this. I have a code snippet for this. So we'll go here and we'll call this dad app. And what this has got is the CLI commands I would need to be able to go out and work with this. Now, my app name, I called it the dad app. I'm going to call the resource group, we're going to call this my London. Actually, we're going to do this. We'll take this and say $app name. And the app name is going to be London 24. So what I'm going to do using PowerShell is I've already done my Azure CLI commands, which you can use to go out and do everything Azure, like set your resource groups and do a lot of the work. I rely on it very heavily for a lot of things. But I can use this to go out and create the app name, and I can run some deployments. So if I do an F8 on that, that sets that value. I'll set this value, and then I'm going to come down here and create the Azure resource group for us. And the resource group got created for London 24 ARM. I put it in the central US. That's home for me, but not for here. I could change it. But then I want to go out and do the AZ deployment group create. And what this command does is it takes my ARM template and will do that deployment for me from the command line. And one of the nice things is I could put on here some parameters. So my parameters I'm going to pass in automatically is going to be the app name. If I take that off, and I just run this, so let's go up here and just do an F8. It's going to then prompt me saying, okay, well, here's what I've got. First of all, is a file there. I need to provide a parameter for this, call it London 24. Say okay, oops. Do this down here. And then it's going to go through, it's going to load the ARM template and then do that deployment for me and run that out there. Any questions about ARM at this point? So it'll run, it'll create that. If I had added some tags to it, which I probably should have done, then I would be able to go out and see that the tags would have gotten applied into the resource group. But in the interest of time, I come over to this. ARM is good, but it's got some challenges. It's very verbose. There's a lot of details. It's JSON, JavaScript object notation, which is not human readable. Well, I mean, it's human readable, but it's not meant to be like you're carrying on a conversation in JSON. If you're writing AI and GPT and stuff like that, and you're passing in JSON packets of like prompts and stuff like that, yeah, you might be used to it, but it's not the way normal people think. And so in order to make ARM easier to work with, Microsoft had a project called Bicep. And they thought Bicep would animate the ARM. And what it is it's a transpiler, which means that it is a language that has as output ARM. And I can actually take ARM templates and decompile them into a Bicep syntax. Nice part about it is it's very modular. It supports all the resource types natively out of the box because it is Azure ARM, so it's the Resource Manager, so it's native to every version of every API that's published is native to Bicep. It is a domain-specific language, though, just for Azure, which means, yeah, if you're doing AWS, you're doing New Relic, you're trying to create stuff that Terraform can do and other things, it's, yeah. One of the nice things about it is that the Bicep language itself is very similar to Terraform. I saw some hands of people that are using Terraform today, and you'll find that the Bicep language is very, very similar to what Terraform is. So similar that I think if you're using one and switching between them, it's like you have to remember there's just a couple little syntactic things. But it does a few things differently than Terraform 2. It does have variables and parameters that are really well defined. The basic Terraform file itself is over here. You'll see that we've got something called a target scope, which is going to be resource group, management group, subscription. I can target different levels of things. I have decorators that will attach to parameters. I've got variables section, I've got resources, and I have modules. And the modules are a path to a file that is in the path of where I'm working. And so when I go out and I'm working with Bicep, I can easily iterate between them. So if I go out here and cd into our infra, actually I don't even have to do that because I've got this right here, is I can run this command, az bicep decompile, and I can path in where that file is. So I'm going to take this file, and what it's going to do is the Bicep tool is going to decompile it and create a Bicep file representation of that ARM template. And so this is the Bicep version of it. As you can see, I've got my parameters at the top. I've got a description. I've got a default value of equals to something. The same way I would do that in other languages, I'm able to go out and kind of describe my parameters, which have to be inputs. I've got my variables. Variables, I'm using the dollar curly sign and then whatever the variable or parameter name. So this is a known thing that came from the parameter. Down lower, I could use dollar site or the site name or host name reference, things like that. When you go out and you create a Bicep file and go to do a deployment on it, it would actually take this and deploy it exactly like that. So here we can say, instead of doing this, let's do this. We're going to say environment is equal to $env name. So we'll just pass that in. And this is a nice way to get started creating these. We'll change this to be Bicep. But working from an existing, yeah, is there a question over here? Yeah.
You shouldn't use $sign without string interpolation, right?
Say that again, the $sign?
Yeah. But below, it's red. Because it's not using string interpolation. So you can just use it without...
Ah, good catch. Good catch. So, when I said the demo gods be with us, that's someone in the audience that catches that. Thank you.
Yeah, or you can just do without. You can use the end name, right?
Right.
Yeah.
So in this kind of a format, I can go out and I could go out and work with this. A lot of people, though, are going to start from scratch. So if I had a main.bicep, and so here I'd have my target scope is equal to, say, subscription is equal to subscription. And then I can say resource, and I can say RG. We're going to create a resource group in here, and I type in resource group. Notice it's going through the IntelliSense and finding all of those different things. One of the nice things I like about it is it also gives me all of the versions of schema, so I'm not going out to Google them and find which schema am I working with. When I do that, I can say equals, and then I get required properties. So the required properties allows me to go out, and then it knows just those minimum required properties. So in here I could put in my RG name, RG-London 24 Bicep. And I would normally go through and say, let's do this like that. West Europe. I'm hard coding it. Notice the little curly squiggly, it doesn't like that. It says, you really should do it a different way. But the point is that I can use modules in here, and I could say, here's my site. And let's undo that. So I go module, site, and then it says, here's the files. And I can either use an ARM template or a Bicep template. It doesn't care. But if I do that and I say equals and it says required properties, it knows the parameters that are part of that module, so it automatically fills that in. From a editor perspective, it's nice to be able to do this. Because when we do Terraform, it's like, in order to go out and figure out what the Terraform resources look like, I end up going out to the registry, copying and pasting, going back and forth, and doing a lot of iterations on that. If I take this and do a deployment, it would deploy the same way that the last one did. And I could pass in parameters from the command line. In the interest of time, though, I want to move on to Terraform, though, and onto Pulumi, because there's really a lot of other good parts that make this story work. Bicep parameters, I've got my descriptors, I've got allowed values, I can set variables. I use a pattern where we define what the naming standard is and we create a prefix and then we apply that prefix to all of the other things so you get some consistency on names. Then we go out and create that, you put the name into that, and you can go out and get started with it. Questions about Bicep before we move to Terraform? Terraform is another tool that goes out and automates the REST APIs that are part of Azure to create resources. It does it through a language called HCL, which is the HashiCorp language, although they might have changed the name of that. But it's basically a proprietary language that describes out what your infrastructure looks like. You create resources. Nice thing about Terraform is it is cross-cloud, cross-platform. It uses a provider model where I go out and I write a provider. There's a provider that Microsoft wrote for Azure. There's one that's AWS. There's one for Google. There's a provider for New Relic. I've used it to create stuff in other tools like Datadog to go out and create monitoring things. I can use the Terraform to animate that and run those things. If there's not a provider, you can actually go out and write your own provider to do things, which is very nice if you've got a complex infrastructure you need to run across different things. Install it is simply getting the Terraform executable on the command line. Inside of a Bash Linux environment, you can use, is it Gem? Or there's a way to install it, but in Windows, I use Chocolatey. You define a workspace as being a folder, and then within that folder, you've got variables that get set. I initialize the environment. I can set up different things. I use TF and TFVAR files to define the infrastructure, and I can have any number of these together. When I run the Terraform plan and Terraform apply, which are the commands, it'll take all of those files, concatenate them together, and then run a plan that shows us what that would look like. Providers look very similar to what a Bicep provider resource looks like. The provider is the tool that goes out and creates the resources for me. The resources define what they look like. We define variables. So the same way we have variables inside of other tools. I've got the type, default values. I've got lists. I can go out and use a local section, so I can define my names inside the local section. I do this a lot, where I create the prefix, and I use that, again, to make sure we've got some naming consistency. And then you create the resources themselves. And the resources then would follow something like that. You use the commands init, plan, apply, destroy are the 4 key commands. There's also a Terraform show, which will show a plan. There's also Terraform state, which allows me to update and manage the state from Terraform. So to show you what this looks like, I'm going to open up, and I will put into this code over there, the Terraform stuff. But basically, what you end up with is you have your Terraform, which has got your required providers. I think it's version 3 point something larger than that. Let's do this. I'm going to create a folder inside of this. We're going to call this Terraform. And then the screen goes black. And then inside of here, I'm going to create a file. I'm going to call it main.tf. And just a very simple main.tf, I can say my Terraform provider. And then once I've got my provider defined, I can go and say resource and The IntelliSense is too smart here. Azure RM resource group. And if I do the resource group, it would then fill in this, but I'm going to cheat. And I'm going to create a resource group. And the thing about this is that I want to show is when I take this folder, TF folder, and change my directory to it, and go Terraform init, what it's going to do is it's going to download all of the providers I've got defined up here, any plugins I've got. It'll connect any modules I've got. So it's got all of that stuff gets put into some folders. You can see it added a bunch of Terraform files here. Now, I can go out and I could say git ignore star Terraform. And it'll then highlight those, do an asterisk on that also. But I can then take this and I could say Terraform apply. And it would go out and take those files. And since I did not specify a state file, it's going to create a state file in that directory for this. And so then I pass in the name, yes. And I know this is contrived, but we've got a limited amount of time. You can see that it created a file here called TF state. And the TF state file has the state information for what I created. And if I open that up, it's just a JSON file. And you can see that in here, it's got the information about all of the different parts of that. Now, one of the things that you need to be aware of is that the state file contains information about the entire infrastructure. So if I create a SQL server, there's a password that gets created with it, or a website, there's a password that gets created for going into things. Now, this is another version of this in a different place that I created this. This has got a resource group, it's got a plan, it's got the app site. If I go here and I say Terraform apply, and cd infra /Terraform, then it's going to go out and it will basically say yes, go out and create this, which then goes out and it updates the Terraform state. So this is going to create the actual app service plan and some other things. But one of the things that Terraform state is that that's where anyone else that's doing infrastructure as code needs to be able to connect to my Terraform state, wherever that is. So a lot of times, if you're working with the cloud, they've got a storage account, like an Azure storage account in Blob Storage or in Google or AWS, and you'll put your state file up there. But it's a text file, JSON, that has all of the values of everything that I've done, including passwords in plain text. Just the same way I did that first time. Does anyone see a problem with that? Does that mean you shouldn't use Terraform? No, but it does mean if you use Terraform, be aware of this and make sure you lock down that file with ACLs, access control locks. Make sure that you keep that file secure, because if you don't, you run the risk of other people being able to find those values. So that's the one thing about Terraform that I would suggest being aware of. It's cross-cloud. Yeah, question.
The state file is not redundant. There's no other place where the state is saved. In the moment when you apply the template, you get one state file and you have to keep that and save that and secure it.
I need to secure that.
Yeah.
So in the Terraform language, I can define that state file is not in my local directory, it's somewhere else. That's the way I normally would do this. And in fact, I do that if I'm in GitHub Actions, I connect to a blob storage somewhere.
Can the state file be regenerated if it gets corrupted or lost?
If the state file gets corrupted or lost, can you regenerate it? Not easily.
Seems like a flaw in the product.
You can import from an existing resource group and create what would be the Terraform for that. There's a Terraform from, at least from Azure, that I know that you can go out and do that. We're doing that with a couple of, one of my clients today. One of the challenges with that is when you pull a template that was maybe created from people clicking around in the portal, you end up with some really crazy stuff, and it's not well-written code. And it's like, it's impossible. Infrastructure as code is no good to you if it's not well-written code. Poorly written code is poorly written code. So it's better to be able to get to where you've got the well-written stuff. See, when this gets done, I'll show you what the state looks like. But in the interest of Terraform, any other questions? I mentioned Pulumi, and I want to talk about Pulumi real quick. Pulumi is...
Quick question about the
Yeah.
state files with the plain password
Yeah.
secrets and stuff. Like, you can use a key vault though, right? To like access stuff? Or yeah? Or no? No? Okay. So it's always a mistake. Okay.
You can add that secret into a key vault, but the values in the state file, because it's using that to determine whether or not other things have changed. And it's a known concern that people have had about Terraform for the 3 years I've been using it. And to my knowledge, there's no plans to change that.
So you can't have like a path to a secret in a key vault in the state file and then it accesses the key vault somehow, no?
During the deployment, not that I know of.
Okay.
Not that I know of. There might be something there today, but to my knowledge, I don't know of a way.
Pulumi does that.
And Pulumi is also, but I'm storing my state and other information with Pulumi. There's also, I'm using the Terraform, I should have mentioned, there's a paid for version of Terraform where they manage your state, but then they've got a copy of what that state is.
Yeah.
And yeah, you can log it to other people, but part of the people I've been with, like financial institutions, don't really like other people having our state. Yes?
When Terraform is comparing the state file to what's currently deployed, doesn't it look at the resources.azure.com, look at the JSON there, and does that actually go directly to the resources and inspect them via the SDK or something?
Good question. So the question is, does the Terraform look at the actual state when it's creating the plan? And the answer is no. It creates that plan based on what's in the state file. When I do the Terraform apply and it collides with it, then it will throw an error and say, oh, your state is out of sync. And then I use the Terraform state command to be able to import into that state whatever it should have been there. And from an infrastructure as code, when we talk about perfect world, people are creating, all their infrastructure is code and doing their deployments like that. But then something breaks and someone goes in the portal and they change the size or they change the scaling rules or they give access to someone that they shouldn't have. And then you go and run your infrastructure as code. It's like, hey, something changed. You have to get to that maturity level of where you don't touch you pick how you want to go out and manage that. Great question though. Yeah.
I believe that is not correct. Terraform, before deploying something, it actually reaches out to the cloud, reads the state of the object, compares, and that's how it creates the plan. So it reads what's out there, compares what's the currently configured, and then says, I'm going to change this because over there the password was changed or something like this.
So what you're saying is that it does look at the actual state when I do the plan.
Yes.
You could be right. I'm a consultant.
I've been using it like 10 years.
Yeah, okay. So what this guy said, my understanding was that when I create the plan, it wasn't looking at the actual values, but when I did the apply, it would then...
No.
Okay.
Transformation doesn't care.
Okay.
Terraform doesn't change.
Okay. Okay, that's good. Thank you. Thank you. Yeah.
Sorry, so in practice, in your experience,
Mm-hmm.
large enterprises, is Terraform reliable and stable, or is it fragile and people spend their lives patching up state files?
I have found it to be stable. I have found that Terraform is a very solid, good solution. And in the interest of time, because we are running a little bit over the time which I had intended, I do want to kind of jump back in here and go to where we've got kind of a stand-up kind of a matrix between these guys. So if I can get over here to this. And Pulumi, I'm creating infrastructure. And if I'd had time, I would have shown you where you can go to the Pulumi site. But it basically allows you to create a C# file to create infrastructure as code, because it is as code. I think of it as more as infrastructure as product, because it's like I might have something where I'm running an application where I want to create a storage account that my clients would use. And so I create a bunch of these storage accounts. And rather than doing a Git repo with what those are, store it in a database and have that generate the infrastructure. Pulumi is a wonderful tool. There is, on their site, they've got some really nice things. So like, for instance, if I come over here to my Pulumi login here, you can see that I've got a dashboard. I can create a new project. Nice thing about Pulumi is I can go out and say, hey, I want to create a web app with config values for env name and color in Azure using C# or TypeScript. Click on the next, and it goes out and generates code for me that would be what this looks like. And yeah, this is a GPT, large language model interpretation of this, but the tools are getting better. I can pick the language that I want to do this in. So I've got JavaScript, TypeScript, Python, Go, C#. I'm a C# person. You can even create Terraform. But when it gets done thinking, it would put the code that I would use here. And in a Pulumi site, then you end up with something that looks like this, where I've got a stack that I create. And the Pulumi stack has, like here's my stack where I've got an app name, I've got a resource group, and when I create it, I'm creating it with some parameters. And I create the plan, and the plan comes in with some parameters as well, and it's got some values that I set to set the different parts of it. That's what it looks like inside of a C# program. In TypeScript, I import the Pulumi namespace using node npm. Then I can create a resource group using the name. I've got the kind is Linux. I've got some values. But I basically can go through, and there's my environment for my favorite color and environment name. When I want to deploy it, I go Pulumi up, and it uses the Pulumi service to go out and then process that and run my infrastructure out. From a high level, Pulumi is a very interesting tool, but I have not yet had the opportunity to use it in production. I have friends and colleagues who have, so it's a solid tool. From a language, yeah.
What's the difference between Pulumi and Terraform as a CDK, their version, essentially?
What's the difference between Pulumi and Terraform?
So Terraform now have a CDK, so you can also write C#.
Mm-hmm.
Specific
Okay. Tell you what, I do want to make sure that the next speaker has time to get set up here. I'm going to be around for a little while, but if you've got questions, I'll be out here in the hallway and I'll be downstairs. I think it's downstairs. But the idea of ARM is it's the native Azure. Bicep is an easier way to do ARM. Terraform cross-cloud, similar language. Pulumi, you write your own code to go out and do things. If you ask ChatGPT, you can copy that slide. I like Terraform. I use it all the time. My paying projects, most of them go there at some point. Bicep is nice because it's an Azure specific, but it is a domain specific solution. So, any questions? I am on LinkedIn. If you scan the LinkedIn, I will answer any questions. I'll help you find anything you need. I'm here for you if there's anything I can do. Thank you very much.